Alrighty, folks. So we'll work here today, obviously, with a video lesson. We'll go in with exploring some new terminology for our rotational angles. So we're going to be putting our angles on the Cartesian plane, right? Your Cartesian plane having an x and a y axis. And we'll do so in a consistent and certain way that allows us to come up with some patterns, to come up with some shortcuts, to come up with some observations that are going to be very helpful as we work forward in this chapter. So first of all, our Cartesian plane, it can be split up into our four quadrants: quadrant 1, 2, 3, and 4. We always label them with Roman numerals like this. We always start in quadrant 1 where x is positive and y is positive, and then we go in a counterclockwise direction all the way up to quadrant 4. Now, when we're working within these quadrants, we use what's called a terminal arm and an initial arm. So an angle, theta, is measured between an initial arm, which is always in the same location. This initial arm is always our positive x-axis, and that's where our x values are positive. That's on the right-hand side of our vertical axis. Our terminal arm, that's what can move around. So depending on where the terminal arm is, our principal angle will have different values. So right here, this example terminal arm is in quadrant 2, and so this angle is measured in between the initial arm and the terminal arm. So we're working right here. Now, this angle, we say this is in standard position if its vertex lies right here at the origin, which it does. So we can see our terminal arm meets our initial arm here at the origin. And the initial arm lies on our positive x-axis like we already discussed. Okay, great. So when we're defining our angles like this, then we're going to work in a counterclockwise direction for our positive angles. And that's easy to remember because that's the same direction in which we labeled our quadrants. So we start in quadrant 1 and we measure a positive angle. They go in a counterclockwise direction. So we would have a 90 degrees right here. We would have 180, 270, 360 degrees all the way around. All right, so then a negative angle would be measured in a counterclockwise direction. So if positive angles go in this direction, a negative angle goes in this direction. So negative 90 degrees is here, negative 180, negative 270, and negative 360 degrees all the way around. Now, okay, so let's practice these a little bit. We're noticing right here, we have, and I apologize, this was, looks like it was photocopied or scanned at some point with poor quality, and that's okay. So we'll work here, we have 150 degrees. Okay, so the first thing we check, if we're working with an angle, we check to see is it positive or negative. In this case, obviously it's positive. And if it's positive, that means we measure the angle in a counterclockwise direction from the positive x-axis. So we need to go 150 degrees in the counterclockwise direction from the positive x-axis. So we'll need to be a little bit careful here. Okay, we need to ask ourselves, we look at these arrows, we ask ourselves, okay, which ones represent positive angles and which ones represent negative angles? Okay, so this one here, the arrow is going in a clockwise direction, so this is a negative angle. Okay, that's not going to be useful to us for part A. Here we have a clockwise direction. We can see that the angle goes around like this, sorry, a counterclockwise direction. So here we're working with a positive angle. The third one right here, we're working in a counterclockwise direction. That's negative. Here it's clockwise, so that's positive. Counterclockwise, number 5 is negative. And here, sorry, clockwise, this is negative. And then I have a counterclockwise. This is a positive angle right here. Okay, so that's great. So we have 3 options here for 150 degrees. The 3 options are in a blue square to represent a positive. I'm not sure why I chose blue for positive. To represent a positive angle, a positive direction in which we're measuring. So Then I ask myself, okay, 150 degrees. What do I know about that number? Well, I know it's greater than 90 degrees. So that means I will have to be not in quadrant 1, because in quadrant 1, that would be in between 0 degrees and 90 degrees. So then I look a little bit further. Okay, quadrant 2 would go from 90 degrees until 180 degrees. That is where this angle lies. So we're expecting this angle to be in quadrant 2. We double check with our positive options right here. I'm working in quadrant 1. I'm working in quadrant 1. I'm working here in quadrant 4. And over here I have quadrant 1, quadrant 2. That's where my angle is. This is 150 degrees. So if you think you follow the logic right here, pause the video, try out option B right here, and it appears as if there are only 6 diagrams, but there are 8 angles. So not every single angle will have a diagram, will have a sketch for us to work with. All right, try them out, and if you're still not sure, we'll play around with B together. So B, we know we're working with a negative angle. It's a negative angle because there's a negative sign in front of the 120 degrees. And if it's a negative angle, that means we're working in a clockwise direction. Okay, if we're working in a clockwise direction, then our options are option 1, option 3, and option 5. If we're working with 120 degrees as the magnitude, so negative 120 degree angle, that's going to be in between negative 90 degrees, negative 90, that looks like this, and negative 180 degrees. So if we're working here, and we know we're working in between negative 90 and negative 180 degrees, we know we should be working in quadrant, hang on, 1, 2, 3. It's quadrant 3 that we're looking for. So can we check option 1? Yes, that satisfies this. Option 2 does not, because they're working in quadrant 2 there, and option 5 also does not. So we have here angle B, negative 120 degrees. Try out the rest on your own. Try matching each. It actually might be more beneficial for you to work from the graphs to the angles up here, because obviously not every one of these angles has a sketch to go with it. Try them out, and I'll say pause the video here, try them out, and when you come back, then you'll see all the solutions. Now, C is kind of a funny one, because that does not fall in between 0 and 360 degrees, and we're used to working in between 0 and 360 degrees, or rather in between negative 360 degrees and 360 degrees. So we'll play around with this. If we're working with 765 degrees, that means we have to go fully around our circle. First of all, it's a positive value, so we need to work in a counterclockwise direction. We need to go fully around the circle at least once. So we go all the way around the circle once. That's 360 degrees. Okay, and then if I go around the entire circle one more time, then I'm working with 360 degrees plus 360 degrees. That's 720 degrees. Okay, well, 720 degrees, that's less than this, so we will have to go all the way around a circle a second time, and then it's a little bit more than that. How much more? Well, if I take 720 degrees and I add 45 degrees, that's where I'm looking, so I'm expecting another 45 degrees. I can see this here is represented with sketch 2. 765 degrees. Good, and so we can see here, and I'm hoping you paused and tried to work it out on your own. We can see here that D can be found here with graph 5. That's a negative angle. E can be found here with graph 3, again, a negative angle. F can be found here in graph 5. This is a positive angle, a little bit more than 270 degrees. And graphs angles G and H do not show up here. Fantastic. Okay. So now let's look at a little bit more terminology. Now that we're getting used to working with these angles, hopefully, a principal angle. A principal angle is the first positive angle, and that's our key, the first angle that's positive to reach the terminal arm. So our principal angle will always be, if it's always positive, then it's going to be greater than 0, greater than or equal to 0. And if it reaches the terminal arm, and it's the first angle to reach the terminal arm, then we'll never have a principal angle greater than 360 degrees, because that would mean we go around the full circle more than once. So let's see right here. If we're working, if we have a Cartesian plane here, we have an initial arm across our positive x-axis. It always goes there, remember. Sorry, I'm trying to fix my zoom. There we go. And we have a terminal arm, and our terminal arm, we can play around with it. I'll draw it like this at first, and you can see that our terminal arm could be anywhere around the circle here. Now, let's say we make the terminal arm right here. Our principal angle will always be, always, it will come from the initial arm in a counterclockwise direction, and it's going to be the first time we hit our terminal arm. Now, that might seem a little bit obvious to you. Yes, that's how we were just measuring them, but you'll see what the other options are in a moment if you didn't clue into them in the last example. Now, a coterminal angle. That's going to be an angle that shares this terminal arm as another angle. So this can have a positive or negative value. So if I'm working over here, all right, that was my principal angle. My principal angle should be labeled with theta there. If I'm looking at a positive coterminal angle, I could work something like this. I could go all the way around once and then hit the coterminal angle. Where in this case, and we could call this theta 2, in this case, theta 2 could be calculated by taking theta and adding 360 degrees to it, because we've just gone around the full circle one extra time. So theta 2 would be equal to theta plus 360 degrees. Okay, that's great. Are there any other options for coterminal angles? Absolutely. So we could work in here, and here I'll work really small. We could work in a negative direction. So we could go all the way around here, and then we hit our terminal arm. And if we're working in this case, then we could calculate our, we can call it theta 3. Theta 3. Theta 3 by working with, again, 360 degrees. It equals 360 degrees minus our principal angle. Because we could see here, if this is the case, then theta 3 plus theta would both equal a full revolution around the circle. And if they both equal a full revolution around the circle, then it would be true that theta plus theta 3 would be equal to 360 degrees. All right, so I hope you're following here. Now, we can have any number of coterminal angles. In fact, there are an infinite number of options. If we're calculating them, all we're doing, we're adding or subtracting 360 degrees any number of times. All right, good job us. We're making some good progress. We're understanding what we're doing. We'll push on forward. We're getting there. Now, let's work with 385 degrees. Okay, so let's try and sketch 385 degrees first of all. If we're sketching it, we need a Cartesian plane. We need a y-axis. We need an x-axis. And our initial arm is always along the positive x-axis. Good. So if we're measuring this angle, we go in a counterclockwise direction for 385 degrees. Now, where am I expecting 385 degrees to lie? Well, I know it's more than 90 degrees. I know it's more than 180 degrees. I know it's more than 270 degrees, which would be 3/4 of my way around. I know it's more than 360 degrees, which is a full way, which is a full way around my circle right here. How much more? It's 15 degrees more than 360 degrees. So if it's 15 degrees more, I should be working with something like this. Something about there. So I'll need to sketch in my terminal arm. And there we go. Okay, so my principal angle here, I can calculate. So first of all, I'll label that. Well, we just inputted in here. What we sketched was 385 degrees. Now, my principal angle is measured from my positive x-axis in a counterclockwise direction, and it's measured until I hit my terminal arm the very first time. So in this case, it's a very short principal angle. How short is this principal angle? Well, again, the difference is 360 degrees from this 385. So if I work here, 385 minus 360 degrees, and I work with, oops, did I say 15 before? I meant 25. So this is a 25-degree principal angle. Our principal angle labeled with theta is equal to 25 degrees. Well done, folks. All right, so we have our principal angle. Now we want to come up with one positive and one negative coterminal angle. How do we come up with these? Well, we're told right here, we add or subtract 360 degrees any number of times. All right, so, excuse me, bear with me here, folks. So then, what I can do is I can just add, okay, so if my theta is equal to 25 degrees, I could say theta 1, we can call this our positive coterminal angle, is going to be 25 degrees plus 360 degrees. Okay, then I'm working with 385 degrees. Now, depending on what I'm working with, I would say that these two are coterminal angles. But 385, that's what I started with. So let's go find a new one. Okay, if we're trying to find a new one, we'll call it theta 2. Then we could add 25 degrees plus 360 degrees plus 360 degrees. Okay, so that's going to be 25 degrees plus 720 degrees. I'm working here with 45 degrees. That is a positive coterminal angle. Good job, folks. All right, what if we're working with a negative coterminal angle? If we're looking for a negative coterminal angle, okay, we'll call it theta 3. We're going to be working here, and we have 25 degrees, that's our angle theta, and we could subtract 360 degrees. So in this case, your coterminal angle would be going in a clockwise direction around to the terminal arm. All right, 25 degrees minus 360 degrees, I'm working here with negative 335 degrees. So our positive coterminal angle is right here. And in fact, you could argue, depending on what you're comparing it to, you could argue one of the above two angles as well. And your negative coterminal angle, negative 335 degrees. Your principal angle is right there, 25 degrees. Well done, folks. I feel like this is relatively straightforward. It might be a lot to pay attention to as we're working forward because it might be a lot of new stuff, and that's okay. But at the very least, we're able to follow along, and if you need to rewind the video for a little bit, by all means, go for it. Listen to these explanations as often as you need. Alrighty. Now, our last new term here, a related acute angle, or last new piece of analysis that we'll use is our related acute angle. So the related acute angle is always going to be the acute angle, and if it's acute, that means it's less than 90 degrees, less than or equal to 90 degrees, remember. It's the acute angle between the terminal arm and the closest x-axis. And you might say, well, hang on, Mr. Pasatka, I already know about my x-axis. There's only one of them. It lies horizontally right here. And you're right, but we're going to split it up into two halves. We're going to split it up into the positive x-axis and the negative x-axis. So our related acute angle is shown by angle alpha. That's what this looks like right here. It looks like a little bit of a fish with an open tail right here. All right, so alpha always represents our related acute angle. If we're coming up with it, my advice is to take a look at your terminal arm, and in this case, that's the red arm again. Take a look at your terminal arm and draw an angle in both directions to the x-axis, and then you want to work with the angle that you just drew that is the smallest, because that's going to go to the closest x-axis. So in this case, our related acute angle will fall on the left-hand side because that's a much smaller angle. That's the only one that's acute. So in this case, our angle alpha can be found over here. That's great. Now, depending on in which quadrant our terminal arm lies, we're going to use a different strategy to come up with alpha. So we need to be ready. If I'm working right here, we compare alpha to the closest x-axis. So in this case, my alpha, and sorry, my screen's frozen a little bit here. So in this case, we're working in quadrant 2. So in quadrant 2, we're comparing to this 180 degree angle because that is the closest x-axis. Now, my related acute angle, along with my principal angle, it makes up this 180 degrees. So I would write here, okay, 180 degrees is equal to my related acute angle plus my principal angle. And that's going to be the kind of logic that we use to calculate our related acute angles as we work forward. So let's try it out. If we're working here, if we have 170 degrees, 170 degrees. All right, well, we should know about how to sketch that right now. So we need our vertical and our horizontal axes. We're working with 170 degrees. I know that angle. It's more than 90 degrees. I know it's slightly less than 180 degrees. So I'm going to come up with this angle right here. And I'm working 170 degrees. I'm expecting something about like so. And let's try and zoom in right there if it allows us to a little bit more. Fantastic. So we need first, well, we're going to need a terminal arm. So let's sketch in our terminal arm. So my principal angle right here, 170 degrees. Good job. Now, if we're looking for our related acute angle, then we ask ourselves, okay, are we going to go towards the positive x-axis or the negative x-axis? Here it's very clear the negative x-axis is much closer. So we're going to be using that. Our related acute angle falls in here. Now, your related acute angle is the angle between the closest x-axis and your terminal arm. And that means if it's the angle in between, then it's always going to be positive because it's always a difference angle, if you will. So your related acute angle, always positive here. In this particular case, we know we're working, and we know that 180 degrees is right here. And you know what? I'll work in orange because we're trying to find the related acute angle. We know 180 degrees is right here. So we know 180 degrees is going to be equal to my angle alpha plus my angle theta, my principal angle. And that's great. I can now substitute in the value I know for my principal angle. That's 170 degrees. And now I can rearrange this. I can subtract 170 degrees from either side. I'm working with 10 degrees on the left, and this is equal to my related acute angle. That's how we find it. Now, are we always going to be adding together two angles to 180 degrees? No, but we are going to be doing that every single time that we're working in the second quadrant. All right, so let's try it out right here, 210 degrees. This time, we're not working in the second quadrant. This time, 210 degrees, we can start drawing it. Okay, we know that's more than 90 degrees. We know it's more than 180 degrees. How much more? A little bit more, but it's going to fall in this quadrant right here. So I have now sketched, oops, I should sketch my terminal arm in red. I've now sketched my principal angle, theta, and it reaches around in the counterclockwise direction towards my terminal arm right here. Good job, us. Okay, so I have this 210 degrees. Now, my related acute angle, is it going to go in the counterclockwise direction, sorry, in the clockwise direction or in the counterclockwise direction? I can see right here, one of these is a much smaller angle. That's the one we want. Our related acute angle, in this case, lies again between the negative x-axis and our terminal arm. So we're working here, and this time, and this is the key, this time, okay, we have 180 degrees right here. And that's again, actually, we'll work in orange. We have 180 degrees right there. But this time, my terminal arm falls after the 180 degrees. So this time I know that 180 degrees, if I add them up, 180 degrees plus my related acute angle, that's going to be equal to my principal angle this time. And you see the difference in how these are built. The difference in how these are built comes from the quadrant in which we're working. Sometimes we're adding to 180 degrees, sometimes we're adding to our principal angle theta. All right, so we're working here. We have 180 degrees plus alpha. Will it let me zoom in there again? Yes, it will. Fantastic. We can rearrange this. we can subtract 180 degrees from each side, and I know my angle theta, my principal angle is 210 degrees, so 210 degrees is equal to this. I subtract 180, 210 minus 180, I'm working with 30 degrees over here, is going to be equal to my angle alpha right here. So in this case, my related acute angle is 30 degrees. All right, we'll go over one more example together in here, and then I'll leave you with D and E on your own. I'll ask you to try those out. But first, we'll work with 60 degrees. Okay, so with 60 degrees, we know 60 degrees lies in the first quadrant. How do I know that? Because 60 degrees is less than 90 degrees. So I know I'm working with something like this. I need a terminal arm. There we go. I have my angle theta. Now, again, my related acute angle is always sketched in between my terminal arm and the closest x-axis. So let's sketch the two options here. I know I could be working over here, or I could be working with a related acute angle over there. I find the smallest orange arrow that I just sketched, so that means I'm working over here. Now you might notice that my orange angle right here is the same as my blue angle. They cover the same distance in between the positive x-axis and my terminal arm. So in this case, it's nice and easy. My theta is equal to alpha. My angle theta, my principal angle 60 degrees, is also my related acute angle. That's going to happen if you're working in quadrant 1 and if you have a positive theta in between 0 and 90 degrees. So try it out for example, 3D and 3E. If you're a little bit stumped, these have an extra little wrinkle in them. If you're a little bit stumped, that's okay. Just at least pause the video, try it out for 30 seconds or a minute, and then double check your work. And there you have it. So for part D, you can see the work in here. Our angle alpha is 60 degrees. And for part E, again, you can see our work in here. Our angle alpha is, oops, it looks like it disappeared on me, is 30 degrees. Well done, folks. Just our last example here. I apologize for the video that drones on a little bit. Example 4. So we have a related acute angle. It's 35 degrees. The terminal arm is in our third quadrant. So let's head out here. All right, and we'll draw our terminal arm. Quadrants 1, 2, quadrant 3. That's where we're looking. Our terminal arm can go somewhere like this. Good. So our related acute angle is 35 degrees. Our 35 degrees is going to be here. No, it's not. It's going to be over here because it's smaller. So we're working over here. Okay, so our related acute angle is 35 degrees. Now we need to come up with the principal angle theta. We'll come up with that together. I'll let you folks find your positive and negative coterminal angles on your own. So our principal angle theta, we know we can come up with this by sketching it out. Your principal angle always comes from your positive x-axis. That's your initial arm. It goes in a counterclockwise direction until it hits the terminal angle, the terminal arm, the first time. So our sketch looks something like this. And from this sketch, we can come up with a bit of an argument. So we have 180 degrees right here, and I know that 180 degrees is part way, but not all the way to my terminal angle. I need to my terminal arm, I need 180 degrees plus my angle alpha to reach my terminal arm. So that's going to be equal to my angle theta. All right, nice and easy from here. 180 degrees plus alpha. Alpha is 35 degrees. And this is equal to theta. Okay, good job. 180 degrees plus 35. I'm looking at 215 degrees for my angle theta. Fantastic. From here, you should be able to find a positive and negative coterminal angle. Try it out. This completed note is posted already on the classroom. Let me know, folks, if you have any questions.